I'm Jansen from the US Naval Research Laboratory, and I'm going to present FlashFlow, a secure speed test for Tor. This is work with my colleagues Matt Traudt and Rob Jansen. Tor is an anonymous communication system used by over 2 million users daily. It sends over 250 gigabits per second of traffic, and it consists of over 6,500 relays around the world. A challenge for Tor is that because its relays are run by volunteers, those relays have varying capacities. That is, the speed at which they can forward traffic varies, and also those capacities are unknown to the network overall. However, user load should be balanced across the relays in proportion to their capacities in order to maximize throughput. This is particularly challenging for Tor because Tor has security as a goal. An insecure load balancing system could allow an adversary to attract to cheaply run relays a large amount of traffic, which will put it into a position to run known de-anonymization attacks against a large number of users at low cost. The current solution to this problem is a system called TorFlow. In TorFlow, relays monitor themselves and estimate as their capacity the maximum amount of traffic that they've seen themselves relay in a 10-second period. There's also a set of bandwidth authorities. Each bandwidth authority periodically selects a pair of relays and downloads a test file of a known size through that pair. Load balancing weights are then determined from the self-reported capacities by adjusting them by the relative speed to the downloads through that relay. There have been several deficiencies observed about the TorFlow system. One is that it's insecure. Published attacks have shown that an adversary can inflate the weight of its relays up to 177 times. The system is also not very accurate. It has been observed that the weights of the relays vary much more frequently than the capacities of those relays do. And one study showed that 20% of Tor relays have over 50% relative standard deviation around their mean of the weights. TorFlow also can't reliably measure capacity. It's only intended for generating good load balancing weights. But Tor does need a system to estimate the capacity of its relays, in part so that it can help plan for the future of the network as client load increases. Our solution to these problems is a system we designed called FlashFlow. In FlashFlow, measurements are run by a measurement team consisting of a coordinator and a set of measurers. During a measurement, the measurers send as much traffic as they can through a target relay for 30 seconds. And the capacity estimate is taken to be the median speed observed among each of those 30 seconds. Relays also allocate at most 25% of their capacity for background client traffic, that is traffic that is coming from normal Tor users. An advantage of this design is that it is more secure. Because background traffic is limited to at most 25% of the relay's capacity, at least 75% of the relay's capacity must be directly demonstrated to the measures. And so an adversary can only lie about a potential 25% that it claims exist, which might inflate its weight by 33%. The system is also accurate, in part because it doesn't depend on the existence or non-existence of background traffic. The traffic needed in order to determine a relay's capacity is largely generated by the measurers. The system is also fast. The measurements are short, 30 seconds, and several relays can be measured simultaneously as long as the measurers collectively have enough capacity to measure those relays at the same time. In order to test the accuracy of FlashFlow, we implemented it and ran a live Tor relay that responded to the FlashFlow measurements. We created a set of teams, measurement teams, distributed around the internet, and ran several experiments with each of those teams, varying the capacity of the target relay by limiting it to as little as 10 megabits per second and as much as its true capacity of 890 megabits a second. The results show that we generally were within 10% of the true capacity, and except for one experiment, we were always within 20% of the true capacity. In order to measure how the FlashFlow weights would change the performance of the Tor network, we ran simulations in a shadow network. A shadow network is a simulated network that allows us to consider a Tor network in which all of the clients used a completely different set of weights, those generated by FlashFlow. We ran a set of shadow experiments using TorFlow weights, where those weights were themselves determined in shadow, and a set of shadow experiments using FlashFlow weights. Again, those FlashFlow weights were themselves determined within a shadow simulation. Our shadow simulations were of a network that is 5% of the current Tor network, scaling everything down to that size, including client load. That client load was considered at current Tor levels and also extra load levels of 15% or an additional 30%. The measurement results show that the download speeds for the Tor network when using the FlashFlow weights were faster overall than the download speeds when using the TorFlow weights. And in particular, for the slowest 10% of downloads, the FlashFlow weights yielded half the download time or less than the TorFlow weights. We also observed that using FlashFlow weights nearly eliminated errors in download. That is, those downloads that failed to complete were nearly non-existent in the FlashFlow experiments as compared to the TorFlow experiments, where the median error rate was 5% at the 100% client load. For future work, we're working on incorporating the FlashFlow design into the Tor network. We've open sourced the FlashFlow code. We have co-written a Tor proposal with the Tor project, explaining in more detail how we would incorporate FlashFlow into the Tor network. And Tor is currently running a set of transient speed tests where traffic is actively pushed through relays in the manner of the FlashFlow design in order to experimentally examine how the overall operation of the entire real network is affected. And you can see in this graph here that covers the estimated and used bandwidths of the Tor network over a period during which one of these speed tests was active. And you can see that the speed test noticeably increased the self-reported capacity of the network from around 600 gigabits per second to around 650 gigabits per second.